This video, I want to spend a moment to kind of elaborate on the idea of the momentum versus net force and the direction. The direction is really what we care about. Okay, and this has to do with circular motion, objects that are moving in circular motion. Okay, so here I have an electron that moves near a gold nucleus. Okay, and there's your nucleus. There's your nucleus. Okay, it's positively charged. The electron is negatively charged. And you can see at different points, we have the electron. The electron is shown. Okay, now this diagram just gives us the direction, and we're going to fill in those questions in. But the idea of not getting this right, that's not what we want. We want you to understand what's going on with the circular motion business. Okay, so we have the electron orbiting around the proton. Okay, and it's moving in a circle. So the question asks, what is the direction of the momentum of the electron? The momentum. So the momentum of the electron. Okay. Well, at point one, what is the direction of the momentum? Well, remember we said that the momentum is kind of like it's tangential to the motion. And so at point one, the momentum, the direction of momentum is actually right there. It's going right there. It's a tangent line. Okay. And so if I take a look at this, okay, at point one, the direction of the momentum matches my arrow D. So at point one, D would be my correct answer. At point two, what would be the direction of my momentum? Well, at point two here, it's always tangential to the motion. And so at point two, my momentum is actually going straight along that. All right, tangential to the motion. And so this looks like it represents C. Okay. So that's the direction of my momentum. Now, what about point three? Well, at point three, again, it's always tangential to my to the motion, and so if I draw a tangent line there, you can see the direction of my momentum. So at point three, that looks just in line with B. Okay. So at point three, the momentum is going in the B direction. So that's the point I want to take. That's the point I want to take. You guys want to take away from this. Whenever we talk about direction of momentum, we talk about the direction of the path itself. Okay, that's tangential to the path. So in the same direction, in the same direction, in the same direction of the path. We draw the closest line, the closest tangent line to approximate the direction. Now, what about the direction of the net force on the electron at each point? So what would be the direction of the net force at point one? So at point one, remember we said that the net force is always towards the center. In a circular motion, when we're moving a circular motion, the net force is always towards the center. And so at point one, my net force will actually be pointing in this way. Okay, so at point one, my net force is actually pointing straight towards the center. And that looks like a perfect line to represent C. Okay, now what about two? What would be the direction of net force at point two? Well, at point two, again, the net force is always pointed towards the center. And so if I'm taking a look at this, the net force is actually going all the way up. Okay, all the way up, all the way up. And we say this looks just in line with A. Okay. And then what would be the net force? What would be the direction of net force at point three? Well, the direction of net force is actually coming towards the center again. So that looks like it represents G. Okay. So that would be the direction of the net force. So that's how we compare the momentum versus the direction of the net force. Okay. It's very important that we know this concept, because you might see some similar question like this on your exam. Okay, and maybe I shall ask one last question. So at point three, the speed of the electron is what? Is it increasing, decreasing, or not changing? Well, at point three, the electron is actually approaching zero. Yeah, so at point three, electron is actually approaching zero. And so the speed of the electron is actually decreasing. Yeah. So that would be the correct answer. So the speed of the electron is actually decreasing at point three.